Hello, welcome back to Diary.io. In this video, we are going to be talking about SSH. Before we start talking about what SSH is, what it's not, how it's configured, and things like that, let's quickly get some terminologies out of the way. So let's get to it. Number one, client server. Anytime you hear client server, we're talking about two different computers, but it depends on what role either of them is playing. Both can either be a program on the computer or the computer itself, and while one of them sends a request, which is the client, the other receives and processes the request, which is the server. Just like when you're browsing the internet, the browser itself is the client, in this case a program or a software like Google Chrome, and the server will be the website that you're actually trying to access. Like Facebook.com is just some computer somewhere in the world. We don't know where it is, maybe in Silicon Valley, I don't know, but whichever of Facebook's server is sending back the request is the server. So that's what client server is. The next one, network protocol. Any established set of rules that determines how data is transmitted between different devices is considered a network protocol. Just like saying how things are done between devices. There are a few standard protocols like TCP, IP, HTTP, FTP. They're just rules of how data is being sent across between computers. Number three, algorithm. These are sets of rules or a process which needs to be followed to solve a specific problem, commonly used in calculations. So if I said an algorithm used to compress a file means which set of rules are being used to decide how this file is being compressed. The next one is packet. Generally, when data is being sent between computers or devices, more like when you attach a file to your email and you're trying to send it, the actual data is being fragmented into what we call packets. So not all the data is sent at once, it's the unit of that data that is considered as packet. The next one, payload. A payload is the actual data within the packet. Even though I said packet is the smallest unit of the whole data that's been sent across computers, but each packet also contains some metadata, which is not part of the data itself. So within the data, the actual data is what is considered as a payload. And finally, remote server. Any computer that is not physically attached to your keyboard or mouse or monitor is considered a remote server. It's not physical to you, it's somewhere else. If you're in London and another computer is in Dubai, that computer in Dubai is considered as the remote server. So now that these terminologies are out of the way, what is SSH? First off, SSH stands for Secure Shell. It is a cryptographic network protocol, which means a standard set of rules that is being used to transfer encoded packets over the network. It was introduced in 1995 by a guy named Tatu Lonen, and the main reason behind why it was created was mainly to address some security issues that similar tools that were used to transfer data over the network or that were used to connect to remote servers over network couldn't address. And some of those tools were Telnet, RLogin, RSH, and using standard username and password to connect to remote servers. Before SSH, none of these tools had a way to encode data that gets sent over the network. Meaning, if some hacker was sniffing packets traveling across the wire over the internet, that means raw packets could be extracted, put together by hackers to get your credentials. I mean, you can imagine if a hacker is able to get hold of the root credentials to access a bank's production server. Everyone is roasted. So what is this problem that SSH is solving? Number one, being able to connect to a remote server in a very secure manner is the biggest win, because I can just sit down in London and connect to a server in Dubai, connect to a server wherever it may be in the world, and I'll be working on the terminal as if the server is connected to my monitor or my keyboard or mouse, and I can send instructions from my keyboard and it gets interpreted by the server wherever it may be. And all of this is happening in a very secure manner, and of course that's better, it's safer than just putting password which is not encoded in any way. And that's why in most Linux and Mac OS based systems, SSH comes already installed by default. So let's talk about how it works. SSH uses asymmetric cipher for encryption and decryption of packets. Before we go even deeper than that, what exactly does asymmetric cipher mean? Now, before we talk about asymmetric, what does symmetric mean? Symmetric cipher uses the same key to decrypt and encrypt data. That means if you have just one key and you have a data, the same key can be used to both encrypt and decrypt that data. Asymmetric cipher, on the other hand, uses a key pair. It requires both the public and the private key to both encrypt and decrypt data. If one is lost and the data has been encrypted already, you can never decrypt the data. How the encryption and decryption happens depends on the algorithm that is being used to do the encryption. And there are many encryption algorithms such as the RSA, DSA, ED25519, and so many others. The more complex the algorithm is, the more difficult it is to decrypt the data. Now let's take a brief look of how SSH uses asymmetric cipher to A, establish connectivity between client and server, and B, send encrypted data across the channel. First, a key pair has to exist, which is the public and the private key. It doesn't matter who creates the key pair. It could be the client who creates the key pair, it could be the server, it could even be a completely different server entirely. It doesn't matter. And by the way, you cannot use a public that belongs to another private key with a private key that completely belongs somewhere else. So it has to be a pair that belongs to each other. So the client shares the public key with the remote server, and by the way, the public key can be shared with anyone. It doesn't matter if it goes over the internet, because that's why symmetric cipher couldn't be used. With symmetric cipher, if you sent the only key across the internet, it could be stolen by the man in the middle. So that's why we're using asymmetric cipher. So now that the remote server has the public key and the client has the private key, to determine whenever there is need to establish connectivity in the first place, the remote server has to be sure that the client is who he actually claims that he is. Because it's possible for someone in the middle to hijack the request and impersonate as though it's the client that's trying to connect, whereas it's someone else. So for that not to happen, the server has to find a way to confirm that the client is who he says that he is. So what the server does is, once it receives a connection request from the client, it uses the public key that it has to encrypt a data. So that data could be anything. It could be some random text. For the sake of explanation, let's assume it creates a text that says, hey, I just started learning DevOps. So it uses the public key to encrypt that data so that the text can become some encoded data. Now, server sends this data all the way to the client, and because the client has the private key, which is the pair to the public key that was used to encrypt the data, the client is able to decrypt that data, and then the packets that gets returned to the server is in clear text what the server had encrypted. Even if there was a man in the middle and he receives the encoded data, he won't be able to decrypt it because he doesn't have the private key, except for some way he's been able to get hold of the private key. Other than that, he will never be able to decrypt that data, and if he sends any wrong data, the remote server will cut the connection immediately, saying, hey, I don't know you. Now, in the event that the client and server are able to establish a trust, remote server becomes happy and confirms that you're actually who you say you are, and then it allows you to connect to it. At this point, SSH creates a tunnel between the client and remote server for data exchange. And to explain what a tunnel is, think about the internet as a huge city like New York or Dubai or Lagos, where I grew up, where there are roads and bridges and all that. The internet is such a very busy place, a lot of different traffic passing through. So a tunnel is essentially SSH creating its own traffic in the middle of all of that busy roads and bridges and traffic and all of that. This tunnel created by SSH becomes the special pass-through between the client and the server, where they can exchange data, and whatever passes through that channel is encoded. They keep sending data and packets back and forth to each other in encoded format, and only when the client receives that data, it's able to decrypt it with the private key it has. And like I said before, as long as the man in the middle doesn't have the private key, that tunnel becomes the safest and secure tunnel in the world. For SSH connectivity to work, you need the client tool that allows you to run SSH commands. On Linux and Mac based systems, it's already built in. If you're on Windows and you want to be able to use SSH, you need to install tools such as PuTTY, Cygwin, Git Bash, or PowerShell to use SSH. Now let's talk about the disadvantages of SSH. There are several ways in which you can use SSH. It has a configuration file. You can extend its functionality to not only connect to just one remote server, you can consider a server as a hop to another remote server, and there are so many things you can do with SSH, trust me. Having said that, any misconfiguration with SSH can completely log you out of the system without ever being able to connect to it again. It is that secure. So even though it might sound like an advantage, in some cases that can be considered as a disadvantage. And the other one is the fact that if your private key gets lost, then again, you're roasted. You can't get into the system. Now, these are the two major disadvantages I could think of. If you have any other things you could think of, please leave a comment in the comment section below. And if you've liked this video, please like, subscribe to the channel, share the video, and hit the notification button to get update every time I release content on DevOps technologies. Thanks for watching. I hope this has been informative for you, and see you in the next video.